Okay, let's do these two things here. Let's do the number 3 first. Oops. Okay, let's do number 3 first. So this is to write correctly the formation reaction of a chemical compound. What we look for? We look for a chemical equation that will be correctly balanced, first of all. Second, to have the physical states of the components of the equation, reacting product to be at standard state. That means the lowest energy, that Gibbs energy we'll call later, right? Lowest. And you really do not know what they are, but some of them you do. Some of them, if you do not know, the problem should give it to you. But in this case, you really know. We already talked about carbon in the form of, allotropic form of graphite with lower energy, thermodynamic liquid. Speaking Gibbs energy, actually, we mean. We'll see what that is later. So most thermodynamic states form for carbon is graphite. Hydrogen and oxygen is not diatomic. Diatomic is monatomic, diatomic molecular gas, and this standard condition for oxygen and hydrogen is not atomic. It's diatomic molecular gas in this condition, right? And then ethanol, that's CH3CH2O. Ethanol is a liquid under this condition. Okay, so you need to have these physical states there. And third thing, besides balance equation and the correct physical states, another third thing you need to be aware of is that the formation equation, the reaction which presents the formation reaction of the substance, refers always to per mole of the product. So it has to be balanced in such a way that you have 1 mole of product. So if you have, like the first one, which is 2 moles, immediately you reject it, right? You have to have 1 mole. You balance it according, starting with 1 mole of the product, and then accordingly you balance all the reactants, right? So in that way then, the correct answer should be C, right? The correct answer should be C for number 3. Okay? Are you done? Let's do a problem with critical temperature. How about that? It's kind of sometimes confusing. Do problems with critical temperature, right? What do you think? Isn't it? Sometimes. So let's do this problem. Let's do problem 4. Try to do this problem, see if you can do it, and then we're going to try it together, right? Do this problem without being really confused. You need to consider something here. It's good to put the temperature first. Which of these 3 gases is non-permanent gas, right? At 177 degrees Celsius. So you have to be careful because the critical temperatures of the gases are given in Kelvin, and you want to figure out which is a non-permanent gas, means permanent gas is which one? The temperature we are talking about is above its critical temperature, right? That's the permanent. The non-permanent is the temperature you're talking about should be below its critical temperature. So that gas will have higher critical temperature, right? But to do these comparisons, you have to have the critical temperatures and the temperature of interest that you are going to be, the gas to be, is to be the same units. So in order not to be confused and make a mistake, perhaps here it works, but sometimes it might not work correctly. You have to have the same units, right? So you have to convert the 177 degrees Celsius, you have to convert it into Kelvin. So how much is 177? Plus, right, 273, isn't it? Correct? That will become Kelvin, right? Is that right? You have this equation on the last of your date of your exam. So Kelvin, it will be 273 plus Celsius. So that will be 450 Kelvin, right? So you start from temperature 400. So your reference temperature, your gas, it's I'm sorry, the room temperature here, right here. We have the gas, right? The gas is at 450 Kelvin. The gas, so we have different gases, right? What's the different critical temperature of the gases are? You have 290, which is the smallest one, 290, and then we have Kelvin, right? Then we have 290, 298, 298, and then we have what? 310, 310, and then we have what? 400, and then we have what else? 500. Right? So from all these gases, you can see only that one has a critical temperature above this temperature. If we were above this temperature, above its critical temperature, this temperature we're talking about, the gas is at, was above its critical temperature, no matter how much pressure you will exert, you will always be goodbye. That's a permanent gas, right? If you are at temperature, if you are at the temperature below its critical temperature, that's going to be a non-permanent gas, right? So the only gas that's going to be non-permanent will be the one that will have a critical temperature above the temperature of interest, which is this one here in the square. So that should be 500, and 500 is gas D. Right? Everybody got it? It's a little bit hard to process it, isn't it? So you have to be careful. If you do it this way, I think it's pretty easy to do. Right? Everybody got it? Okay. Otherwise, it gets really busy with this.
Do you want to use the fastest equation, the actual